there's a link that's replace StreamSpark. I think we covered this towards the end of the class, but just to make sure. There's a link that's replace StreamSpark. You're going to follow it. You're going to create an account. When you create an account, use a school address. And at a certain point, it'll probably say, need to confirm your educational status. In which case, it'll send another confirmation email to your school address. And then once you've done that, you're going to get to a page. I don't remember which one I needed. And for Pete's sake, now I'm getting... Let's grab the Chapter 2 PowerPoint, and we'll just get on our way. All right, Introduction to C++. The parts of a C++ program. Here's our sample. This looks pretty similar to what we probably did past 2 days. We have a comment up at the top, and I'd prefer to see your name, right, in your class section up there as well. Then we have a # include. We will quite often have a whole bunch of # includes. Right now we don't. We have this using namespace command. I'll show you what that means actually next time we create our file. We have a function declaration. Function declaration is just like in Python, except in Python you use the def keyword. Here we don't use the def keyword, instead you use the data type. It's going to return a number, you use int or float or double or long or something like that. If it's not going to return any value at all, because not all functions have to return a value, use the word void there. Then you have a block, and inside the block we displayed something, an output statement, cout. This is called an output stream, IO stream. There's also input streams. Input streams, CIN, the arrows are going the other way. CIN, greater than. And then a return statement. And we tacked on something just for our own convenience, but only the Windows users should be doing it. System pause, like that. Preferably without the backwards double quotes that Word applications and PowerPoint and stuff have, right? But anyways, if we typed that into C++, it would have looked okay. So there are special characters. // is the beginning of a comment. A hash is the beginning of a preprocessor directive, of which we've only seen a few. I think I showed you # define, and we've seen # include. Then there are the opening and close brackets, which do two things. One thing, they enclose file names in # include, and also when they were paired up, less than, and greater than, they work with input and output streams. Parentheses. Open and close parentheses are used to contain the parameters of a function, if it has any. If it doesn't have any function parameters, you just don't put anything between the parentheses, just like you saw here. Nothing there. Opening and close braces marks a block of code, group of statements. Open and close double quotes is a string. There's one that they're leaving off here because it's not in the example, but single quotes rather than double quotes is a single character. Python didn't distinguish between the two. You could use double quotes and single quotes interchangeably. Not true in this language. In this language, double quotes is always for multiple characters or a string of characters. A string of characters can consist of nothing, by the way, right? Or it can consist of 1,000,000 characters, whatever you want to type there. Double quotes, though, double quotes are always a string of characters, but a string of characters may not be anything, in which case it's called an empty string. That's an empty string. Single quotes, on the other hand, mark a character, and there's always one thing, one and only one between the apostrophes to mark a character. Now, we're not going to do much with the character data type. We're usually going to use the string data type, so we're almost always going to be using double quotes. And then the semicolon, the end of a programming statement. Does every line end in a semicolon? Well, if we come back here and look, no. There's no semicolon there. There is a semicolon there. There's no semicolon there. Your rules of thumb is no semicolon for preprocessor commands, the ones that start with # and there's never a semicolon before an opening brace. Other than that, yeah, there's pretty much going to be a semicolon on every line. Oh, and not the braces themselves. You don't put open brace semicolon, close brace semicolon. Might work, but we're not going to do that. So the cout object, called the output stream, or the console output stream. That's what it stands for, console output stream. Displays output on the computer screen. So cout, arrow, arrow, programming is fun. Now, if we did that, it would not go to the beginning of the next line when it was done. It'd just leave the cursor flashing right there after that message. So to make it go to the next line, we would tack on a backslash in there. Or we would do this, arrow, arrow, ENDL. Arrow, arrow, ENDL does the same thing as a backslash in. It causes it to go to the next line when it hits it. They're pretty much identical, except this one goes outside of any quotes, and backslash in has to be inside the quotes for it to work. But this is identical to doing that. Again, forget the fact that Microsoft is messing up with forward and backward quotes. You could send more than one thing to cout at this. If you print out hello space followed by there, that's going to display this. Hello there. That's exactly what we're going to see. Or this example down here. Print out hello and go a space, but there's no backslash in there, so it's not going to go to the next line. So it's going to print hello, not jello, followed by the space and then the word there. And again, it's not going to go to the next line because there's no backslash in there. So our example should have backslash in there and backslash in there in order to be strictly correct. Anything that begins with a backslash is called an escape sequence, or an escape character. Escape because it's stepping out of the ordinary mode of processing. Right now it's printing something. I'm going to print a T, an H, an E, an R, and an E, and an exclamation point, and then, whoops, something special. What's that something special? In this case, it's to, go to the next line. If it was like a typewriter, just go tick, tick, or if it was a printer, or, since it's going to the screen, it's going to send a cursor to the next line of the screen. It behaved differently. There are other escape sequences. There's one for tab. There's one that goes back to the beginning of the current line. It doesn't backspace over it. It doesn't erase everything. It just moves the cursor back to the beginning. Like in olden days, if you were going to underline something on your typewriter, you'd backspace to the beginning of that line, and then you'd start adding underlines. There's one to add quote symbols, backslash double quote, or backslash single quote, or there's one to add a backslash to your text. Right? Because if these backslashes are so special, how would you actually display a message on the screen to add a backslash? You'd have to use 2 backslashes. We'll give demonstrations of that. So this is one line of output. Programming is fun. If you did that, it would print programming is, and go to the next line. Fun, and then go to the next line. So you can use what's known as the ENDL manipulator. I like how we have to use fancy words. Manipulator to start a new line of output. So this will show 2 lines of output. Programming is ENDL fun. And again, there should have been something at the end of that one to prompt it as well. So we add this, cout arrow arrow, quote, I love arrow arrow, whoops, end quote, arrow arrow, ENDL, arrow arrow, quote, rock and roll, and then one more ENDL. It's going to print, I love, it's going to go to the next line, rock and roll, and it's not going to go to the next line until it hits that one. Then it's going to go to the next line. There. Now we're ready to go. Cout. Cool. Like that, right? And so that would be on that own line, but I need to put some kind of backslash in or ENDL there to get it to go to the next line again. So every line you see out should probably have a backslash in or ENDL. Exception. What if you're going to ask a question and let them type it in, right? What is your age? Do you want them to start typing it on a line underneath it? Right there, right? In that case, you would use an ENDL there. But what if you want them to type it in right there? Then you wouldn't go to the next line. And the reason I'm making a slightly big deal out of that is if you did do a bunch of Python programming, it always went to the next line unless you went to some trouble to get it to stop. Or if you put it inside the input statement. But anyways, now we know it never goes to the next line unless you explicitly tell it to. I'm going to delete that. So you don't put quotes around ENDL, and that is an L and not a 1. Or you can use a backslash in, but it has to be inside the quotes. So the #include directive. It's a preprocessor command that goes and inserts the contents of another file into your current program to bring in a library of code. So it's not even part of the C++ language, but it's useful. It's built into C++. It could be built into other languages, except for some reason Java doesn't use a preprocessor, even though I think it's kind of useful. I guess they decided it to make things more difficult to understand. So the #include line itself is not seen by the compiler. Instead, it's like a copy of the entire file, and then you highlighted this and hit paste, and it replaced that line. So you don't put a semicolon at the end of the #include line, or else when it did that paste, then there would be a stray semicolon there at the bottom of it. Now, is the file permanently changed? No, it's just a temporary change that we don't see happen while it's compiling it. Variables and literals. What is a variable? I think I've said this, maybe not. A variable is a storage location in memory. It's a little bit more complicated than that. If you took my fundamentals class, then you're used to me saying this and kind of tired of it. A variable's got 4 components. It's got a name, it's got a type, it's got a value, and a memory address. Those are the 4 components of a variable. In most languages, you don't care about the memory address. In most languages, you can't even get the memory address. Python doesn't let you figure out what memory address that data is stored in. Same is true for Java. However, in C and C++, you can get the memory address out, and you can make changes to the memory directly, not using the variable. Kind of fraught with peril. You have to be super careful in order to do that. But so, example, here we have a variable, int x equals 3. The name of the variable is x. The type of the variable is int. The value, pretty obvious, it's 3. The memory address, we don't know. The program assigns it. We usually do not care about the memory address. So I'm never going to ask you for the memory address of a variable. And if I ask you for the components of a variable, I don't care if you only tell me 3. But technically, that's a value as well. Technically, this is known as the state of the variable. The variable has all those components, so that's its current state. What if we have another variable? float f. Well, what's its name? Somebody tell me so I stop pausing. F, right. Whoopsie. What's its type? Yep, float. What's its value? Trick question, it doesn't have a value. Or it has a value, but it's unpredictable. We could print it out. The compiler might not consider it an error. It would produce a warning, at the very least, so saying you're using an uninitialized variable. You better not use an uninitialized variable. You better not try to do math with something that's uninitialized or try to print it out or whatever. You need to stick a value into it before you can use it. And that never happened in Python because the very act of assigning a value to it is how you created it. But here you can create a variable without assigning. Here we have created the variable and we have assigned it. If you do both of those things at the same time, that's called initialization. So, int z, that's the creation or declaration of the variable. Z equals 10, that's the assignment. Int z2 equals 10, this is declaration and assignment, also known initializing. Now this term gets used colloquially to every time you give something a value. Right? Here I'm going to initialize it to 10. Well, you know, you and I understand that it means we're setting it equal to 10 and that it's the first time it's been set. Technically, as far as the computer textbooks go, this is the initialization and this is an assignment. I'm not going to trip you up by asking a quiz question that asks you to distinguish, you know, and messes you up if you called that one an initialization. I'll try not to do that. So they all have a name. They all have a type of data that's different from Python where you did not give a data type. The data type was chosen by Python based on the value that you assigned to it. You said, you know, age equals 10. It figured out that age had better be an integer. Or if you said temperature equals 98.6, it figured out that temperature better be a float. Here we give that type. And once you declare that type, you better not try to change it around. If we have an int, you'd better not try to store a string into it. If you did this, z2 equals hello, that's an error. z2 is an int and cannot hold a string. Different from Python, where it'll just go, okay, I'm going to rejigger that variable. Right? Doesn't mind. It'll just redo it on the spot. C, C++ do not redo things on the spot. Once you declare a variable, it is stuck of being that type. It is a more strictly typed language than Python, where variables can be created on the fly and their data types can change every time you store something new in them. Making a strictly typed language is supposed to make your program a little bit safer, a little bit more bulletproof, because you know you're not ever able to store the wrong type of data in it. The compiler catches it and gives you an error if you try. So this is actually a syntax error, not a logic error. It won't compile. It won't compile if we try to do that, if we try to reuse a variable name that's already been created for something else. If I turned around and I decided that it needed to be a string and I tried to do this string 2, well, it's going to say, no, that variable already exists. So it won't let me get away with that either. There are certain circumstances where you can get away with that, where you could redeclare a variable. I recommend against it, but there are times you can get away with it in this language, unlike a lot of others. So a literal is a value that is literally written into the program's code. If I say age is equal to 12 in my code, if I ever wanted to change that age, if I grew a year older and I felt like making my code match that, I'd have to go and open the CPP file and edit it. It's literally embedded in it. Now that's not probably why they came up with the word literal, but that's how I remember it. It's also known as hard-coded. The number 12 is hard-coded into the program. It's also known as a magic number, right? Magic number because when we're looking at the code, we might not understand what that number is. Like if we see this somewhere deep down into the guts of our code. If we see, you know, if x is greater than 1,000, we don't know what 1,000 is. We don't know why that, you know, if I was just scrolling up and down and I saw that, that's a magic number. I don't know what it means. But if I declared it as a constant, right, const int max price, something like that, equals 1,000, and then later on in my code it said if x is greater than max price, all of a sudden it's crystal clear, right? So if you're going to use a literal number, you might consider making it a constant. Now there are times when that's silly. If you're going to start a counter, right, for x equals 1 to 10, you're not going to do for x equals 1 and have defined 1 up here to be 1. You know, you're just going to do that, right? But if it's something like a tax rate or a maximum value or a minimum value or a year or something like that, you probably don't want to use it as a magic number, as a literal. You'll probably want to make a constant out of it, right? So const float tax underscore rate equals 0.895. I don't know what Midwest City's tax rate is anymore, right? It's probably 0.0895, like that, right? Whatever. That way, down your program down here can use these values, and they all make sense. And if they ever need to change, they can be edited just in one place rather than everywhere you used it. Often these are stored in header files. To make it even more flexible, they might be stored in an INI file. I'm sure that you game players have had the concept of an INI file that you go and edit and change things about the way the program works. So that's a literal. It's an integer literal. This is a string literal. We don't care so much about string literals, but maybe we should, because what if we had to translate our program into French? If all of our string literals were defined up at the top in a header file, it'd be easy to give that header file to somebody and say, okay, translate all these to French. But I don't make you define your constants up in a header file or anything like that. I just recklessly put them in the CPP file right then and there. So today we sold, that's a string literal, that many apples, bushels of apples, and apples is equal to 20. That's an integer literal. Identifiers. The identifier is the name you use for a function, for a variable, for a class name once you're starting to do object-oriented programming. This is an identifier. Apples is an identifier. So is the function name, main. There are rules that identifiers have to follow. So identifiers are variable names and function names, and class names when we get to classes. So there are rules. You can use lowercase letters, lower and uppercase letters. You can use underscores. Microsoft C lets you use dollar signs. I'd be real curious, Lindy, if you try the putting a dollar sign in a variable name on the Mac, like if you do this, int tax dollars equals 20. Next time you write a program, see if that gives you a syntax error. But the PowerPoint very explicitly says that underscores, dollar signs do not work. And the fact that Microsoft does, I consider an aberration. And so, and then you can use digits, lower and uppercase letters, underscores, and digits. But there's kind of a sub rule. Cannot begin with a digit. It can begin with a letter, an uppercase letter, a lowercase letter, or an underscore. It just cannot begin with a digit. So if you try to create a variable name that has a space in it, like tax space rate, that's a syntax error and it won't work. But if you make a tax underscore rate, that will work. So tax rate equals 0.085. That's a syntax error. Tax underscore rate equals 0.085. That's fine. Tax capital R rate equals 0.085. 85. Now, you'll see a lot of Java programmers follow that syntax because that's how the people who made the language do. You'll see me follow that too. You may see the textbook follow that. Underscores are considered a little bit more old school, kind of like 80s and 90s programming. Nothing wrong with them. I like the way they look. I like underscores. This is known as camel case because it's got a hump in the middle. I know that's silly, right? But it starts off small and then it humps big and then it gets little again. It's called camel case. You know. Yearly tax rate. We've got two uppercase letters, right? Two humps to our camel. Many humps is necessary. We can string them all together. How about tax underscore rate underscore 2019 equals 10? That's fine. There's no illegal characters in there. However, if we do 2019 underscore tax underscore rate equals 10, that's a syntax error. Cannot begin with a digit. Here's a silly variable name. It's valid, right? Because underscores are acceptable characters, but it's silly. It's just like naming it A is equal to 3. Even worse, though, right? But it would work. I really wish I'd remember to bring my jacket. So an identifier must be one word. And that's true whether it's a variable or whether it's a function. So I should have been defining these variables as I went along, right? That's a float. That's a float. That's a float. I don't know if these are ints or floats or not because it doesn't have a decimal point, but you know, I'm just going to call them floats anyways. That's a float. That's a float. But this is illegal because it's got begins with a number, and this is illegal because no spaces are allowed. It's got to be all one word, not 2 or 3 or 4. So when we do int, if we're going to declare a function, my underscore function, like that, that's valid. Int my space function, not valid. Int my capital F function is valid. Camel case. All three of those are, the first one and the third one are valid. I'm going to go back and add fine camel case to that one. Camel case is just considered more modern, I think.
Can we begin with the capital letter?
You can begin with the capital letter. I will add a comment to that effect. You can begin with a capital letter. However, don't. Capital letters are used to mean something very specific. They're used for the name of a class. C++ programmers and Java programmers tend to follow that paradigm, is that it's the name of a class and not a variable name. But you can. Nothing wrong with it. You can use all caps if you want. Good programming style is to use lowercase, maybe throw in some uppercase in order to do camel case. That's considered good programming style. Very occasionally you'll see me use an uppercase letter when I'm giving examples up here. Like if I type x equals 7. I ought to just use lowercase all the time because that's considered good programming style. So an identifier is a program name, a variable, a function, a class name. Along with identifiers, you have keywords. Now, when you program Python, you probably use 10, 12 keywords. C++ has a gazillion of them. A lot of these you're not going to use or learn in this class. Some of them I don't even remember what they mean, like explicit, const extra, align up, align as. I don't really know what those keywords mean. I would have to look them up. You'll learn probably about 20 of them and use them. And then if you ever have to learn another one, you can just Google it. A keyword, keywords of the vocabulary of the language, like int, float, and double, and using, and if, and while, and for. All of those are keywords, and there are others. Return. You just can't use these as variable names, right? I couldn't use the word if as a variable name. This looks silly, right? But int if equals 3. No, you could not create a variable called if because it thinks it's part of an if statement. So keywords are reserved words. You cannot use them as variable names. It's real easy to find out that you've done that because it won't compile. I'm going to go ahead and start Visual Studio, so in case we feel like starting to type code, we can do so. Right. You type it into Visual Studio or Xcode, it'll put it in a different color. You try to compile it, it'll give you an error message. You pretty much know that you shouldn't have used that word. Now, as we look at our reserved keyword list, there's not a lot of times I'm going to want to use a variable called mutable, right? Or struct, or while. So, but I might want to use a variable named friend, right? Friend is equal to quote Barney, right? Well, I won't be able to. So variable name should represent the purpose of the variable. If you see I equals 10, you don't know what I means. Maybe the programmer does, but if you hand it to somebody else and it's embedded in 20 pages of code, they're not going to know what I is. However, if they see items ordered equals 10, they're going to know instantly what that variable means. So it's better to give variable names that are descriptive. In general, avoid single letter variable names. Now, I'm going to use single letter variable names all throughout the class. Why? Because it's easy to type and it's easy for you to follow along, and you're not going to mistakenly misspell the letter X, right? You might make it uppercase by mistake, but you're not going to. But in general, you should only use single letter variable names for things like counters, like if you have a for or a while loop, you know, for x equals 1 to 10. It's okay to use x as a single letter variable name, but don't say n equals something if it's really a username. Say username equals, right? Or don't use d equals something if it's a date. Put purchase date equals. Now you can get ridiculous and create variable names that are 40 or 50 letters long, and that's kind of absurd. You don't need to go that far, but just make your code readable. Make it readable to you. If you had to quit your job and then you were rehired 2 years later, you could look at it and understand what it did. Or once you quit, your fellow programmer is going to have to work on it. Don't make them hate you, right? You use good variable names. So identifier rules, it can be an alphabet character or an underscore. After that, you can use alphabet characters or underscores or numbers. Uppercase and lowercase are distinct. There's a big difference between tax rate and tax rate. They mean they are two different variables. And it's easy to make that mistake. We're real used to hitting the shift key when we type in the beginning of a sentence, right? So you're going to have some syntax errors probably at first from uppercasing some things that shouldn't be uppercased. One of the reasons I like underscores is I can almost completely avoid using uppercase letters, right? Other things to take care of is don't use lowercase l if it can be confused with a 1 or vice versa. That's just general advice I give you. So, right, because if later on you had if a equals L, that looks a lot like if a equals 1. This definitely should have been a longer than a single variable letter name if L, was going to be used as a variable. Similarly, capital O and zeros. This font happens to make it clear which is which. Not all of them do. So I would not use a capital O as a variable name, because again, if you did if I equals O, that looks a bit, right? It looks like it's comparing it to 0. Or worst of all, how about lowercase l equals uppercase O? It looks like it's saying if 1 is equal to 0. Just a hint. Try to make sure that lowercase l's and uppercase o's cannot be confusing to look at. I try to avoid them when I'm typing up here. So, if I move this off the screen so that you can't see the answers, is that a valid? Oh, well, it's still showing the answer. There. Is that a valid variable?
Yes.
How about that one?
Yes.
That one's good. How about that one? Nope, because it's got a period in it. There are times you'll see periods inside of variable names, but they mean something very specific. This is the variable name, and then the thing in front of the period is what's known as an object. So you might see something like that, but it's not a valid variable name. And this is bad because why?
No.
Begins with a number, and this would work, but they say it's bad because of the $sign. So don't use it. It's non-standard. And $signs mean something very specific to people using the basic programming language. And so if they saw $signs in your code, they would think that it meant the same thing as it did in their language, so just don't use them. The integer data type. That's a whole number. However, there's kind of subcategories of the integer data type. You didn't have these in Python. Integer data types are whole numbers, right? There's no fractional component. They can be divvied up into signed and unsigned. Signed can be positive or negative. Unsigned means it can be positive only. And why would you make a positive only variable? Usually you won't. I'll almost never in this class create a variable and say that it's an unsigned variable. About the only reason I can see to do that is because if the variable is unsigned, it can hold a value that's twice as large as a signed variable. For reasons we'll talk about in the future, it's known as the sign bit. The first value of a signed variable either gets set to a 1 or a 0, where 0 means positive and 1 means negative, and that bit means that that can't be used to store part of the actual data. Whereas if it's an unsigned variable, it uses all of it, even that first bit, to hold a number, and the number can be twice as large. So, a signed int, the largest value you can store in it is about 2 billion. An unsigned int, the largest value is about 4 billion. But it can't be negative. Don't use unsigned unless you have a real reason for it. But if you do, you just put the word unsigned in front of it, right? Unsigned int x equals 3. There. If you try to make x a negative value, it won't work. Won't be a syntax error. It just won't work. It won't equal -1. It'll equal something significantly different than what you're expecting. Let's play with that. We haven't created any code yet. Let's create some. I think I have my boilerplate ready to go, so I think I'm going to be able to go and open it. Alright, so this is going to be, I'm going to call it CPP underscore lecture C, but you could just call it lecture C or whatever you want. CPP because the class right before yours is C programming, and I need to distinguish my lecture C's. CPP lecture C, it's an empty project, and if it's saying something about repos for repository, hit browse and store it in your documents directory or your Visual Studio directory instead, right? Just find documents and store it there, or maybe Visual Studio inside there. Now, apparently I've closed my Solution Explorer. So if you don't have anything on the right side of the screen and you're using Windows, you do View, Solution Explorer. Now I have my Solution Explorer and I can add a file. And this is different than how it looks in Xcode. And if you need me to learn how it works in Xcode and find my old documentation about it, you can ask me, or you can Google up, tutorial creating C++ file. Okay, cool. So I'm going to add a new item, and I'm going to call it lecture-c.cpp. CPP standing for C++ file. Now I need to find my boilerplate because I'm tired of typing it in. I created some boilerplate and I stored it in this directory. If you haven't, I recommend that you create one, right? Because I'm already done. And if you're trying to catch up, it would take you, a minute to type all that. Go ahead, take a minute to type all that if you got it. But let's create an unsigned variable and then subtract something from it to see what it looks like when it goes negative. Unsigned int age equals 1. Now I'm going to subtract 2 from it. Age equals age minus 2. Now I'm going to print it out. Cout arrow arrow age arrow arrow endl. And look at that. That's a number above 4 billion. It slipped negative, but instead of being negative, it went to a huge number. Maybe you remember old video games like Asteroids or something, where your spaceship can go off the side of the screen and it appears back on the other side. Right? But that means its x-coordinate got below 0, and it wrapped around and gave itself a large x value, rather than try to go negative, because you couldn't draw anything negative off the edge of the screen. Why would it matter? Same thing. It wrapped around here to be a huge positive value when I tried to subtract something from it. That's just a point of curiosity. If you're using unsigned numbers, you're not supposed to let them get below 0. If they do, then you get what's known as overrun. Right past the, gets too large, or anyways, it rolls over and then becomes corrupted data. You probably did not mean for that number to suddenly change into 4 billion just because you subtracted 2 from it. That was just to show a quirk of unsigned numbers going negative. It's the only reason we did that. So there's signed and unsigned, but then also the size of the variable. Something else you didn't have to worry about in Python. Python, you tried to store a big number into a variable and then allocated a lot of space for that variable. C++ is very specific though. I think we've talked about how 8 bits is a byte. Guess what 4 bits is? A nibble. I did not make that up. Isn't that ridiculous? 4 bits is a nibble. Okay, so there's 8 bits in a byte. An integer, either signed or unsigned, is 4 bytes long. Meaning it's 32 bits long. It doesn't sound like much. Only 4 bytes. But it can hold up to a number of 2 billion or so. What if you need more data than that? What if you need something that's bigger than 2 billion? You can do that. You declare an 8-byte data type. And it's got a silly name. And lots of platforms, I bet for our Mac user, you would just use the word long and it would work beautifully. But for Windows, we have to say long, or long int. Either one of those will work. A long is 8 bytes. And so instead of just being 4 bytes, 5, 6, 7, 8, so instead of being 32 bits, it's a 64-bit value. Maybe you remember back, you had your Nintendo and it was an 8-bit machine, and you bought your Genesis or your Super Nintendo and it was a 16-bit machine, so it could hold much larger numbers and the graphics were better. And you bought your PlayStation and it might have been a 32-bit machine or 64-bit anyways. That dictates the sort of data that can be stored in it. So it's 64 bits, 8 bytes. It can hold much, much, much longer values. Much larger values. I don't know the max for a long. I guess we could find one out by creating an unsigned long and subtracting 2 from it, or printing it out. That might be fun. Unsigned long. It's going to be more than 4 billion. Woo boy. I don't even know what that is. It's not trillions, right? It's a huge number. Anyways, so longs are for data larger than 2 billion. Rule of thumb, just use an int unless you know it's going to be astronomically huge. Unless you know it's going to be larger than 2 billion. And then there are still other data types. A char is a 1 byte integer. Usually only used to hold letters. Only to hold typewriter keys. Like char ch equals x, like that. It's only 1 byte long. Meaning it can only store one of 256 different values in it. So its largest value perhaps could be 255. Don't start thinking to yourself that you need to conserve memory by using a smaller data type. I better store all my data in chars because I don't want to waste memory by storing something in something that can hold a value of 2 billion. No, do not think like that. Computers nowadays have billions of bytes in them. It doesn't hurt to use an extra 2 bytes or an extra 3 bytes in order to hold a number. It's far better to do that than to write a program that might malfunction because it's behaving unexpectedly because that value got larger than 255 or went negative or something like that. So that's one integer type. Now we don't normally think of characters as being integer types, but they are because each letter has a corresponding value. A capital A is a 65 behind the scenes, and a capital B is a 66, and a capital C is a 67, and so on. Those are called the ASCII values of it. So then you have what's known as a short int, or a short. That is considered to be a 16-byte value, 16-bit value anymore. 2 bytes. Now these are just kind of recommendations. You could write a C program, a C language, where a short int and a char and a int and a long were all exactly 1 byte long, and it might be a valid language. However, a short, it should be smaller than an int, and a long should be larger than an int. So, you know, at this point in time, these values have kind of stabilized. It's just that Microsoft didn't agree to move along to being what it is on Linux and on Mac. So you have short ints, you have ints, which are 32-bit values, 4 bytes, which can hold numbers of up to about 2 billion. And then you have longs, or long int. 64-bit data types, 8 bytes per variable, hold huge numbers. Huge numbers. But none of these hold decimal points. And so you can mix these, right? You can make an unsigned short. I'm going to take the word int off of it, but these are other int data types, right? But I'm going to move this char underneath the description of these others because it's kind of the oddball out. Usually there's a byte data type as well, meaning it occupies exactly 1 byte. So if I went down here above my system command and I said byte b equals 3, I bet that's not a syntax. Well, what do you know? It is a syntax error. If I really wanted to get away with that, I could use the word char there, or char, C-H-A-R, character, because a character is 1 byte. But usually I just go with an int. That's our rule of thumb. Use an int unless you have a reason to pick another data type. And don't even ask me for a reason to use a short, for example. What is the maximum value for a short? Let's find out. Let's go make our unsigned variable a short. Unsigned long, I'm going to change that to unsigned short, and I'm going to run it. And after we subtract 2 from it, it's going to show the largest value a short can hold, 65535. All right, now we know. So the largest value, so up to 65535. That's the largest value a short can hold, an unsigned short. So a signed short can actually only hold up to like 32,000. 32768. I don't remember what that number divided by 2 is. Well, I guess I could make it a signed short and find out. So normal, ooh, okay. Oh, because it's signed, right? So of course it can go -1, no problem. Up to about 32,000. I guess if I Google up and I type in largest value of signed short, somebody would tell me 32767, about 32,000. So there's no reason to choose short. Don't think to yourself, oh, I'm going to save 2 bytes. It really doesn't speed the program up, and it really is no pain to use an additional 2 bytes in order to store it as an int. Then there are floating point types. Float, not flat. Float stands for floating point. Numbers with decimals, numbers with fractional parts. Example, 98.6, that's a float. 0.001, that's a float. 0.0, you'd think that's an int. It's a whole number, right? It's not a whole number. It's got a fractional component even if that fraction is 0. Right, all of those are floats. Just like with integers, there's more than one type of float. However, instead of being 6 different types of integers plus chars, which makes 7. Why am I saying there's 6? Because you have shorts and unsigned shorts, and ints and unsigned ints, and longs and unsigned longs. So that's 6 different data types plus char is 7. There's only 2 types of floats. There's floats, and then there's doubles. And you Java programmers have already hit the term double before. It's just a double wide float. A float is 4 bytes, and a double is 8 bytes. So it can hold a much larger value. I don't even remember the largest value for a float. But the largest value for a double is astronomically larger. Use double all the time. Never use float. Because doubles are far more precise, you get fewer rounding errors. Uses up a couple more bytes, but there's nothing wrong with it. The default data type in the C language, if you type in a floating point value, is double. So it would have to be converted into a float even if you started to use it. Like if you did this, float t is equal to 98.6. This literal is a double. And then in order to store it to a t, it has to get rounded off and shoved into a float. It takes time. No reason to do that. We may as well just make it a double. Use double all the time. From now on, I'm probably going to never type the word float in again. Double is more precise, holds larger values, is the default type for floating point literals. So I guess the question is, well, why don't you just make everything longs? Because longs are more precise. I don't know. But generally 2 billion is big enough. So let's just use ints everywhere. I admire y'all who type all the notes along. You do know that I'm going to upload them, but I know that it burns it into the brain easier for me if I'm typing stuff in, so I admire y'all for doing that. But I know that some people don't type as fast. If I'm ever going too fast and you're trying to keep up with me, let me know when to slow down. So variable definitions. Int age is equal to 30. Age is never going to get above 2 billion, so I may as well leave it like that. Long national debt equals 16 trillion or whatever our national debt is anymore. I have no idea. Current national debt. 21 trillion. I'm old enough to remember the first time it hit a trillion. It was either during like the last year of Jimmy Carter or the first year of Reagan. So it's 21 trillion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I had to make that a long because it's bigger than 2 billion. Double patient temp is equal to 98.6. Unless we're using Celsius like we probably would, in which case it's 30 or something. I don't remember what the average temperature in Celsius is. This would probably be a syntax error because the default literal type for a whole number is int, and that's not an int. It's too big to be an int. If you need to tell the compiler that something is not an int, it's a long, you tack on a capital L after it. I didn't put a capital L here because that's not a big number. It's not bigger than 2 billion or 4 billion. So the L tells the compiler that the literal, the number, is a long value. It's bigger than 2 billion. If you get a syntax error when you're assigning a variable like that, you can just fix it by sticking an L at the end. Quite often you don't need to, right? Anything less than 2 billion is not going to need that L there. So you don't need to be obsessive about it. You don't need to do long x is equal to 0L. Absolutely no reason for that L because a 0 works just as well, right? It's only if that number is bigger than 2 billion or smaller than negative 2 billion that you need to tack on the L there to get it to compile. On the other hand, there's nothing wrong with doing it. If you feel like being that precise in particular, you can. All right, guys, let's take a little break. You need to acquire caffeine or run to the bathroom or whatever. So integer data types, here they are. I showed you a bunch of them. Short int is 2 bytes. Largest value it can hold is 32,000. An unsigned short int, since it uses that sign bit that I mentioned to hold a larger value, it can hold something twice as large, 65,000. A regular int, in modern computers, it's defined as being 4 bytes long. So it can hold up to about 2 billion. An unsigned int uses that signed bit to double the numbers it can hold, so about 4 billion. A long int. Well, in Microsoft and only in Microsoft C, a long int is considered the same thing as an int. So this is saying, oh, what do you know? This is saying the same thing. That a long int is the same as an int, so it's also 4 bytes long. That's not true if you're using the GNU compiler, something for Linux or something like that. And then a long int is 8 bytes long, so it can hold a really large number. And an unsigned long int can hold one that's even twice as large as that. You can define variables on the same line or on separate lines if they are the same type. It's okay to do int length comma width, or it's okay to put int length int width. However, this is a different data type, so it has to be on a different line. Okay, when I say it has to be on a different line, could you get away with doing that? Yeah, but it has to be part of a different definition, right? Int length width, unsigned int, and nobody does this. There's absolutely no reason to do that. It's considered poor style to try to cram multiple things onto a single line with semicolons. Only rarely does that look like a good idea. So here apparently we've decided that since your miles can't go negative, we're going to use an unsigned variable. Well, then how about days? Why didn't we make days an unsigned long? Don't know. Just an example. So an integer literal is the integer value, like that. That's typed into the program's code. It's literally typed in it. It's a magic number. It's hard-coded into the program. Here's several of them. Our checking amount is -20. Our miles is 4276, and days is equal to 8900. So integer literals are ints by default, and I mentioned this. If you need to make it a number larger than 2 billion, you tack that L on to tell it. Oh, this is saying that you put on an LL. And a single L probably suffice, but I guess I could make the habit of the change to going over to LL. Constants that begin with a 0 are considered base 8. Are we going to talk about what base 8 is? Never. Constants that begin with 0x mean that they're in hexadecimal. Maybe you have heard of hexadecimal, but that's how you specify a hexadecimal number in C. If you wanted to, and you wanted to set a number like this, int x equals FF, because you know what that means in hexadecimal, you would have to put OX in front of it. How many times are you going to do that? Well, unless you specifically need hexadecimal digits, you're not going to do that. But that's what the OX means. Now, does that mean the variable's any different? No, it's the same thing. It's still an integer. It's just that now it's holding the value 255, right? Just because I happen to have memorized that FF in hexadecimal is the same thing as 255 in decimal. Bitwise, they're identical. The int, the data type does not change just because there's an OX in front of that. The char data type can hold a single letter. It's usually 1 byte of memory. You can store numbers in them, though, if you want. But it's designed to hold a character. The number it holds would have to be very small, right? It's only 1 byte. It can only hold a maximum of 255 different values. You have to put single quotes around the letter if you're specifying that it's a char data type. So when we did char letter, letters equal to C, we use single quotes. If you have a string is something that starts with a double quote, ends in a double quote, and out in memory it gets stored byte by byte into computer RAM, but then an extra byte is tacked onto the end, an invisible byte called the null terminator. That tells the computer that that's the end of the string. Otherwise, it doesn't know where to stop processing it. So when we see x is equal to hello there, then somewhere out in memory, there's a variable named x that's got these 5 bytes in a row, but it's actually 6 bytes long because it's got to have that null terminator there. The string class. String handling in the C programming language was really annoying because I won't even go why. But now we have the string class, which lets us assign data and use data much more easily, just like you did in Python or in Java. You create a string variable and you can store any kind of strings you want in it. Something of 0 length, something of 1,000 length, anything between double quotes. You can also display those with cout, just like you could any other kind of data. Now, if you leave off the # include string, it starts to look like it's going to work, and then it later on might not. If I did not have # include string here, leave that up, and then I type string name is equal to Jeff, not Kef, and later on I try to use cin error name, just try to let somebody store something into the name. It gives me an error message. It's saying error. No operator matches these types. Operand types are standard I string. Okay, and you go, I don't even understand why I'm getting that error. Well, the error message is because we did not put the right pound sign include. That's because there is a string data type that was defined as part of the original C++ spec, but it was very limited. And so programmers came up with a replacement string class. But they've kept the name of it lowercase. It would have been nice as if in Java they had named it an uppercase name to differentiate it. But they did not. So depending upon whether you have the words include string up here or not, that's actually a different data type. Always do that. Always add pound sign include string. That's why I made it part of the boilerplate. We need to actually write some programs before long. Floating point data types. The floating point data types, they can hold numbers with decimal points, known as real numbers. They're stored inside the computer as some kind of scientific notation, but it's not decimal scientific notation. It's not base 10, it's base 2, which has some side effects. Let's see if we can demonstrate any of those side effects. I'm not sure I'm going to be able to do this, but let's give it a try. Down here above my pause, I'm going to create a float. Even though I always said use double, it'll probably do it with a double as well. And I'm just going to write a little loop. Not that we've used loops yet, but you've used them in other languages. So we're going to get all fancy and use a for loop. For parentheses, int x equals 0, x less than 20, so it's going to repeat 20 times. And I forgot to say that I typed in a semicolon there. So for parentheses, int x equals 0, semicolon, x less than 20, semicolon, x plus plus. This is the same as a, don't type this, but this is the same as a for statement in Python that says for x in range 0, 20, 1. Those mean the same thing. All right, so we're going to say f equals f plus 0.1, and now let's write it out. C out, arrow, arrow, f, arrow, arrow, ENDL. And let's run that and see what we get. I guess you could just sit there and not do anything. If you wanted to be so rude. It was supposed to print a number there. It used to print a number. Right? Does it work for anybody else? Or when you run it, do you get the blank screen?
You have the CN. That's the types of.
Okay, do I have the which?
You wrote a CN at the top. At the very top. So CN name. It's asking you to type the name.
Ah, you're right. It's waiting for me to type something in. My mistake. Thank you. Thank you all for catching that. All righty. All right. Well, it did not demonstrate the error. But what's the final value of our variable? It's 2. So check this out. If we do f equals f minus 2 and then print f out one more time, C out, arrow, 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 f, arrow, arrow, ENDL, we're not going to like the results. It equaled 2, right? So 2 minus 2 ought to be 0. Woohoo! Does not equal 0. It got a rounding error. That is because this is stored inside it as exponent-based floating point scientific notation, but in binary rather than decimal. And what does that mean? Well, what if you had the number 1 over 3? You can't express that precisely in base 10. We use base 10. But you can't express that. That's why it's an infinitely repeating number. We can get rounding errors if we try to represent 1.33 because, we're only willing to write out so many 3's. We're not going to sit here and write out an infinite number of them. Same thing with floating point values. On this side of the decimal point, it has to equal 1, 2, 1, 4, 1, 8, 1 over 16, 1 over 32, or any combination of those, right? It has to be something that can be cooked up with powers of 2. And point 1 cannot be cooked up by adding any number of powers of 2 together. So it's stored, but it's slightly imprecise. And as we start adding together, the errors accumulate. And so by the time it finally reached 2 and we subtracted 2 from it, that's how much error had accumulated. You have to take that into account when you're dealing with floating point numbers. That's one reason why it's better to use a double, so at least your error is much smaller. Change that float to a double and check out what that exponent becomes instead. It should not be negative. It should not be 0.07. It ought to be like it ought to be to the negative 15 or something. Yeah, negative 16. Much smaller, right? 8 orders of magnitude smaller floating point error. Still has a floating point error. You have to take care when trying to compare floating point values, because if I did this, if parentheses f equals 0, that's not true, even though we expected it to be. You have to do something a little bit different when comparing floating point numbers to accommodate the fact that it might not equal exactly what you expect it to be. So instead, you check to see if it's a little bit above it or a little bit below it. This would be the silly way of doing it. If x is less than 0.1, right? And that means and in this language, f is greater than 0.9, right? That might mean close enough. Instead, we want to define it much more carefully than that and use a different syntax, but that's the idea. You have to check to see if it's within this special range, within a range that's acceptable. I'm not going to focus on that right now. We're going to go back and look at our PowerPoint. All floating point numbers are signed. Can't get it unsigned. Here's the amount of space. A single precision float is 4 bytes long, so it can hold a number up to an exponent of 38, like a 1 followed by 38 zeros. A double Y can hold a number with 308 zeros after it, or a decimal point followed by 307 zeros and then a digit, right? Exponent of e to the 308 or e to the negative 308 for your math folks. And a double is just the same as a double. Excuse me, a long double is the same as a double, so there's no reason to type in long. At a certain point, the specification for C++ will probably be modified to specify that a long double occupies 16 bytes, but right now it doesn't. So you don't need it. A floating point literal by default is a double. So if you absolutely need this to be treated as a float for some reason rather than a double, just like that long business where you put an L, you can stick an F there. But we're not going to use the float data type. So we're not going to be sticking F after our net values. From now on, I keep saying that, I'm going to stop using the float data type and I'm going to use double because it's far more accurate. And I'm not going to need that F suffix. But if I was using a float, it would be better to do this. Float F is equal to that. That's how I ought to do it. I did it, I created it as 0, and there really isn't a difference between 0 and 0F, so I didn't bother, but I should have. The bool data type. Java calls it Boolean. They use the whole word. I don't know why C++ felt compelled to keep it to only 4 letters long when they could have made it 7 and used the word Boolean. It's just a true or a false. Bool, all done equals true. Bool finished is equal to false. Back before the invention of C++ and the creation of the bool keyword, here's what people would do. They would do #, don't add this, I'm probably going to erase it. # define true is 1. # define false is 0. And then they would # define Boolean as the data type int or char or something. And then if they felt like it, they could do this. I have a Boolean flag called finished, and I'm going to set it equal to false. And then later on, I could set finished equal to true, right? Because without that, you just set it equal to 0 or 1. Am I finished? No. 0. Am I finished now? Yeah. We're not in 1970. We like using the words true and false. And we don't need to use # defines in order to accomplish that because it's part of the language spec. So, Boolean finished equals false, right? And then while finished equals false, then do something. I'm probably going to comment all that out because that would be an infinite loop. And that's a Boolean variable. Boolean variable can only be one of 2 values. It's probably a byte long. That'd be my guess. So if we printed size of bool, well, yeah, this is fun. Do this. Cout arrow. My definition of fun might be different than yours. Cout arrow size of with no spaces parentheses int arrow ENDL. And then copy that line and start pasting it 4, 5, 6 times. And instead of an int, I'm going to find out what the size of a short is, what the size of a long is, and the size of a bool, just to see how many bytes each one of those data types is occupying. There we go. 4 bytes for an int, 2 for a short, 8 for a long, and 1 for a Boolean. 1 byte is the minimum data size. You might think, well, what about a bit? A bit is just 1/8 of a byte. Well, you can't tell your computer to go and just retrieve 1 bit. It wants to retrieve data in bytes. And then once it's retrieved that byte into the chip, then the chip can work out the individual bits involved. So that's why the smallest data type in this language, a Boolean value, which is just either a 0 or 1, and you might think that it could be stored in a single bit, instead takes up a whole byte, whole 8 bits of memory. Determining the size of a data type. Well, guess what? You use size of. The size of a double is 8. The size of a float. You can also do size of on a variable name rather than a data type. Right? I have a variable named f. I could print out the size of f if I wanted to. It would tell me. There's a certain point where we will actually use size of. It's not just an academic curiosity to see how many bytes your data stores. When you're dealing with arrays, when you're dealing with lists, they are specifically going to be called arrays, and I will use that term from now on, even though in Python they were called lists. When you're dealing with arrays, you quite often need to know the length of the array. And unlike Java or Python, you can't just ask the data to tell you how many items are in the array. You have to calculate it. And the way you calculate it is with the size of parameter. We will do that when we get to arrays. So the size of that float is 8 bytes because I declared f as a double up here. Variable assignments and initialization. This is the act of assigning. We copy the value 12 into it. kind of three things you can do. You can declare a variable, also known as creating it, like this, int x. You can assign a value, x is equal to 1. Or you could declare it and assign it at the same time, which has a special word of initializing. Special term is initializing. Now people often, it freaks me out when I say something that I'm absolutely sure I said before, and I'm not sure if I said it during the C language or the C++. People often use the first time you give a value initializing. But technically, it's only being initialized if it's declared in the same statement. But I don't care. I've initialized x to 1 here. I'll say that even if it's not 100% accurate, you'll understand what I mean. I have assigned the value 1 to x using the so-called assignment operator. The equal sign is a very technical name of assignment operator. All right, let's do something more interesting than just going page through page to the PowerPoint, because our eyes are going to roll up in our head, at least mine are. We're going to talk about the math operators, the arithmetic operators. Even though we haven't hit a page in a PowerPoint about it, I'm going to talk about it here. I'm going to start a multi-line comment, so I'm just going to put /*. And that way I can type a whole bunch of stuff in here without it being part of the program, and it's going to show up as green text. Okay, math operators. There's really only 5. There's addition, subtraction, multiplication, division, and percent. There's a couple missing if you're a Python programmer. Do you remember ***? This doesn't have ***. Do you remember //, meaning floor division? This doesn't have //. So those are our only math operators. And we know what addition is. We know what a minus is. We know that that means multiply. We know that that means divide. And that means modulus. I bet most of y'all know what modulus is, but we're going to talk about it anyways because it's the one that most people's brain gets hitched upon if you're going to have a problem with any of these. Modulus means remainder of. So if I do this, int x equals 10, I probably have already used x as a variable name. So I'm going to say int a is equal to 10 and int b is equal to a modulus 2. And then I printed b out. If you do know what modulus means, somebody tell me what b would equal at this point. Don't disappoint me. I know some of y'all took my class and you know what modulus means. No forgetting things over the end of June, the end of May. I'm looking at you, Lindy. All right. What modulus means is remainder of. If a is equal to 10, 2 goes into 10 how many times? 5. Once it does, was there a remainder? No, it cleanly divided. So at this point, b now equals 0. What if we did this? A is equal to 11. B is equal to a modulus 2. Well, how many times does 2 go into 11? Whole numbers only. It goes in 5 times. But it's not even, right? It's not evenly divisible. So what's the remainder? And don't say 0.5 because that's not technically right. The remainder of 2 going into 11, 2 goes into 11 5 times with a remainder of 1. So that's what b is equal to now. How about this? A is equal to 5. B is equal to a modulus 2. What is b equal to? Sounds good. 1. Exactly. What if it was 3? 5 divided by 3, take the remainder. What's the remainder? 2. Exactly. You got it. Why would you care about that? Well, You can use those to compare, not compare, but to convert things. And I'll give you an example. What if you have 359 pennies and you want to find out how many dollars and how many pennies that would take, or how many quarters and how many pennies it would take? So if we have int pennies equals 349, and we want to figure out how many quarters and how many pennies would be left over after we exchanged into quarters, we need to remember that 1 quarter equals 25 pennies. And so we can do this. Int quarters equals pennies divided by 25. And then we could do int cents equals pennies modulus 25. And then we could print those out, right? Cout arrow arrow quote pennies equals space end quote. I don't know why I made that uppercase. So end quote arrow arrow pennies arrow arrow endl, and cout arrow arrow, which is space end quote arrow arrow quarters arrow arrow quote quarters. Space end quote. Tell you what, I'm going to put this on the next line. You don't need to do that because your screens are a lot wider than mine. Your font's a lot smaller. Cout arrow arrow quote and space end quote arrow arrow cents arrow arrow quote space cents backslash n. Now I know that was a lot of typing, and maybe it's not going to look good when we run it, but let's see. All right. So if we have 349 quarters and we try to exchange them to quarters, 349 pennies, that's equal to 13 quarters and 24 cents. So we did some conversion there. Now you may have wondered why I created a new variable name here. I could have just done pennies equals pennies modulus 25, right, rather than create a new variable for cents. But that would have erased the old value of pennies. I might want the old value of pennies for something else, right? Maybe I'm now going to calculate the number of dollar bills it would take to give me that. But if I've erased the value of pennies by reassigning it, using it again to hold something else, then I couldn't do that. So I created a different variable. How about pounds and ounces? How many ounces are in a pound? Is it 16? 1 pound in ounces. Yeah, 16. Okay. So, int OZ, short for ounces, equals, I don't know, 279. Just make it up a number. Now, reminder, 1 pound, 1 pound, equals 16 ounces. And if you grew up using metric, you think that all of this is absolutely insane, and you're right. That's all right. So now let's figure out how many pounds that is. Int pounds equals OZ divided by 16. And then int ounces equals OZ modulus 16. Right, the remainder. Once you're done dividing out the pounds, what is the remainder? Now the way we typed that cout statement took too much typing. I'm going to simplify it. cout arrow quote OZ equals end quote arrow OZ arrow NDL. And I'm going to do the same thing for pounds and ounces. Cout arrow quote pounds equals space end quote arrow pounds arrow ENDL. Cout arrow quote and ounces equals space end quote arrow ounces arrow ENDL. And I think I'm going to add the word if here. Right. If ounces is equal to this, then pounds is equal to that, and ounces is equal to that. So I added the word if there just to try to make it make sense to me when I print it out, when I run it. And there we go. If the ounces is equal to 279, that's 17 pounds and 7 ounces. I'm going to assume it's right. You know, I'm not going to whip out my calculator and check. Now, normally, what would you have done? You just would have divided 279 and gotten that it was equal to 17.65342 pounds, right? But sometimes you want to maintain your units, right? Like the quarters and the pennies example. It doesn't help you to find out that that many pennies is equal to 17.43 quarters, right? Instead, you want to know how many quarters there are and how many leftover pennies there were. So that's what modulus means. Final reminder, modulus means remainder. We could write this program so that we ask for the number of ounces, right? The only problem is that once we start asking for input, then every single time we run the program during our testing session, we have to type something in. So at this point, oh, I spelled remainder wrong. Looks French. Remandre. There we go, remainder. Good time to stop and make sure nobody has syntax errors. What would have happened if I had not had this curly braces here? It would not have printed this F 20 times, even though it looks like it's supposed to. It's deceptive. It would have only printed it once. Wherever it is in there, it's only once. I could prove that by printing out, you know, the little letter F, right? I run it. I only see F in here once, even though it looks like it should have been in there multiple times. And the reason for that is because this language does not use tabbing to declare blocks. So what this means is really it's treated like it runs like that. That's actually how it runs, even though it's formatted like that. So we have to have our curly braces and we have to have them in the right place for them to actually work. We're almost through chapter 2. I really don't want to get in the habit of going through one chapter a day. That seems excessive. All right, so when you assign a variable, you have to follow the correct syntax. What do I mean by that? The left-hand side has to be the variable, and the right-hand side has to be what you're copied into that. So that would be a syntax error. I don't expect to see y'all doing that, but every semester I see somebody who has the syntax flipped and they wonder why it's an error. Well, that's why. The left-hand side, which has actually got a special abbreviation. Believe it or not, people call it in programming terms LHS and RHS for right-hand side. See? LHS, RHS. LHS always has to be the variable name, and then the right-hand side could be some expression that's copied into that variable. Variable initialization. If you initialize a variable, as you define it, you also give it a value. Now, you don't have to initialize a variable when you create it. Here's an example of creating some variables, and some of them are initialized and some of them are not. If you feel like it, you could just initialize everything to 0, right? If you're not going to give it a value, you could just go ahead and, you know, do equals 0 if you felt like it. The only reason you would want to do that is to eliminate the opportunity to get one of those warning messages where it said warning using uninitialized variable. But that's actually useful information to know that it was uninitialized. Why? Because maybe you were expecting the user to type in a value there, but you forgot to use your CIN statement, and so it didn't have any data. So it's actually not a bad idea to not initialize your variables if they're going to be filled in at a later point. And that way the compiler will yell at you if you try to use them. What do I mean by that? What if down here I was trying to calculate the number of dollars based on the number of nickels or something, and so I said, you know, int nickels, and then I said int dollars is equal to nickels. There's 20 nickels in a dollar. Nickels divided by 20. That's not going to work because there's no assigned value for nickels. However, it may actually compile. Unlike Java, it's not going to necessarily cause an error because we were using an uninitialized variable. Now in this case it did stop it, but you're not guaranteed that it's going to do that. In which case it just uses some kind of random value, whatever was actually sitting in memory at the time. So that's an uninitialized variable. And it's useful information for me to know that that's uninitialized if I had intended the user to type in the number of nickels, but I forgot to write the code for it. So yeah, there's nothing wrong with assigning 0 to every variable as you create it, if you're not going to assign it another value on the spot, but I wouldn't. I'm going to delete that now. And yes, it's totally legal to declare more than one variable of the same type on one line. I think I've mentioned that the reason I don't like to do that is because I might want to put a comment for every line explaining what those variables are. And if I have 10 variables defined on one line of code, then I'm not going to be able to put 10 comments explaining what those variables are. But if they were all each on their own line, I could. Otherwise, there's absolutely nothing wrong with doing it that way. So int month is equal to 2, days is equal to 28, and it could say the month 2 has 28 days. And here we initialize month to 2 and we initialize days to 28. C++11 has an alternative way to define variables using the auto keyword. This is weird because the auto keyword means something very specific in the C language. The C++ language is supposed to be backwards compatible. And then in 2011, they created a version of C++ where they renamed what the auto keyword did. It's one of the only points that they've done that on. But what it means is kind of like Python. Okay, Mr. Compiler, you tell me what kind of data to store in that, what type it is. So you remember how in Python you did not even have to give a data type. You could just do interest rate is equal to 12.0 and it would have stored that as a floating point. And then if you did this, right, then it would have stored that as an integer or whatever. If we use the auto keyword, and I'm never going to use it again for the rest of the class, it just tells the compiler to pick the right data type based on what is on the site. Oh, looks like a double's coming in. I better make interest rate a double. Looks like a character's coming in. I better make it a character. Looks like a long is coming in. I better make it long. Now, I don't think string works that way. I don't think you could create a string that way and have it actually be the string class. I don't know if a big advantage of using the auto keyword. I'd rather just see the word double there, and the word char there, and the word long there. Scope. It's a mouthwash. So also something else. The scope of the variable is the part of the program in which the variable can be accessed. A variable cannot be used before it is defined. This variable here, OZ, it can't be used here. I can't print out OZ here. Now I know that looks silly to you. You may instantly know what's wrong with it, right? OZ is here. I'm trying to use it there. That's obviously wrong, but there's a time, and I see a lot of students do this when you set something up and you get puzzled as to why it's not working. And I'll show you what I mean. Say I gave you this assignment. The formula for converting triples to quatloos, you're a Star Trek fan, if you know these words and you're a Star Trek fan, is one triple, or quatloos equals triples times 2,500. I just totally made that up. So what some folks will do before they learn better, and then I say write a program that asks the user for the number of triples and calculates and prints the number of quatloos. All right, who's a nerd who actually knows these terms? Come on, guys. Somebody has to have watched Star Trek, the old show with Kirk and the triples and the furry things. All right, I'm just leaving. I'm giving up life now. I'm kidding. Okay. So anyways, write a program that asks for the numbers of triples and calculates the numbers of quatloos. So here's what people will do. Okay, I need to ask for the number of triples. Okay, int t is equal, and cin into t. And then, okay, I'm going to output the number of quatloos. So I'm going to use cout, and display the number of quatloos. And, okay, I better declare my variable. And, oh, what's the formula for triples and quatloos? Quatloos is equal to t times 250. 25,000. Whatever. They'll write it like that. Since the formula was the first thing I put in my specs, it'll be the first thing they add to their code. That's not going to work. Why is it not going to work? These variables haven't been defined yet. The compiler has no idea what Q is and what T are. It's not going to look ahead and go, oh, well, the next time we need them, Q is going to be an int and T is going to be an int. It goes in order. If this is main, right? Don't know what a triple is. I'm disappointed. All right. If you have that, this is not going to work because Q has not been initialized or created. I mean, it doesn't have a value. It doesn't even exist at that point. And so whenever I write some specs and I give you the formula, don't just tack the formula on up at the top of the code. It doesn't help. Now you could turn it into a function and put it outside of main and make a function that converted one to the other. That's pretty cool. But you can't just do that. So here is an example of misstructuring the program, of trying to write code that uses, although you're not trying to, variables before they are declared by mistakenly putting the formula above the variables. So here's the problem description, and there's the bad solution. This is the error. Q and T are not assigned, or do not exist yet. Now maybe that doesn't look like anything you'd ever do, and that's fine. But I have students do it, not because they're stupid, it's just the way they think. Right? In math, you define your formula and then you use it. So in my program, I'm going to define my formula and then I'm going to use it. But you can't do it that way. Your formula has to be after you have your data, or it better be its own function declared, separately in the code. So to fix this, you would move the formula to after where the variables are defined and assigned. Now this program is dumb because it's asking the user to type in a value and it didn't actually display the value, right? So we should have displayed something telling them what to type. How many triples are you selling? Like that. Okay, that's a better program. And now it's not telling you what Q is. right? So it should say, you know, that will be, end quote, arrow, arrow, q, arrow, arrow, quatlus. Quatlus, just a money unit from an episode of Star Trek, and triples were the furry things in Star Trek. Okay, so that line should be moved to right here. This would be the right place to put it in order to get the program to work. Make sense? I'll pay somebody to text me before class to remind me to bring a jacket. No, I'm kidding. Y'all would all do that and I couldn't afford it, but really wish I brought one. So the scope of a variable is where it is alive, where it can be accessed. Value can only be used after it's declared. And it's only available for use inside the braces in which it is declared. What do I mean that? What if I have some kind of if statement down here? If pounds, if parentheses, pounds equals 12, equals 12. I don't know if they are equal to 12 or not. I don't remember from that example. Then we're going to do something special. I don't know what, but we're going to calculate a variable int z is equal to 3 times 2 for some reason. That was real important to us, but only if pounds is equal to 12. If we try to print z out here, if I do c out arrow arrow quote z is space end quote arrow arrow z arrow arrow endl, that's going to be a syntax error. Because a variable's lifetime, its scope, is only within the pair of braces in which it's defined. Python wasn't like that. Just because you declared a variable when it was tabbed, it still existed after the tab stopped, to a fair degree. Not universally true, but to a fair degree that was true. It's not true whenever you're using these curly braces. If you declare a variable inside curly braces, it's only accessible inside those curly braces. Once we get out of it, it no longer exists. So that's an error. If you wanted the value of z to be accessible after the curly braces, you would actually have to declare it above the first curly brace so that it would still exist by the time you got down here. All of these variables are what are known as local variables. Local variables are variables that are defined inside a function. We have a whole bunch of local variables in this because we've been typing for an hour and a half. All of these variables are only accessible inside the main function. If we wrote another function like this, int test, you don't necessarily have to do this. If we wrote another function like this, and we tried to use some of these variables, like see out the name, here's why I say you don't have to do it because I'm going to wind up deleting it all. It's not going to work because name is not defined in here. It's not available to it. This is a local variable. All of these variables are local, so they can't be seen in here. Just like you have some bedroom furniture in your apartment, the other apartment is not going to be able to use it because your furniture is local to your apartment. That's stupid, but you get the idea, right? It's inside this function. It can't be used inside another function. If you need something that can be used by both functions, you have to take it outside, right? You're going to pull your lawn chair out on the lawn, and now everybody in the apartment complex can use it. It's now a global variable. If we wanted this variable to be used both here and here, we could declare the variable outside of all of our functions, like this. And now it's accessible both inside test and main and any other function below. That's called a global variable. I'm going to delete this part, but I am going to leave that part up there, and I'm going to add a comment. This is a global variable because it is defined above the functions, so it is accessible in all the functions in the file. For you Java programmers, it's the same idea of making a class member or a static member, right, of your variable, and then all of your functions, all of your methods inside that class can use it. And so Down here, int ABC equals 1, 2, 3. This is a local variable defined in the function, so it cannot be used inside any other function. So what if you needed to use ABC inside of another function? You would pass it into that function as a parameter. You'd put it inside the parentheses when you call that function, and you'd write that function in such a way that it could get that value and use it. And we've seen using parentheses before. If you've ever done any other programming, you've seen using parentheses to pass data into another function. Global variables are considered poor taste, rude. The only variables you ought to make global are constants. Why? Because if I write two functions that are both using the name function, but one of those functions changes the contents of the variable and I didn't expect that to happen, then when my other function is using that name variable, it would now be wrong. You can have multiple functions using the same variable for different purposes. And you might think, oh, that'll never happen, but you might not be the only one writing the code. Somebody else might think that they could change that value and you wouldn't know that it was changed. You can declare a variable as a constant to indicate that there's nothing that can change it. You would add const in front of it. Now that variable can be used just like it could before, except it can't be changed. If I come down here and I do, this is going to be a syntax error. Name is equal to Fred, like that. That's a syntax error. Python didn't have a constant keyword, but if you took fundamentals with Donna or me, then maybe you learned that you should have typed the variable name in all caps and we pretended it was a constant. Well, we don't have to pretend that something is a constant. We use a const keyword to indicate that it's a constant. And if we try to change the value of it, it actually is a syntax error and it won't let us. So if you are going to use global variables, you might make a constant so that you know that it's not going to be changed later. Or I should say, that's typically what people do nowadays. The modern programming style is to make all your global variables constants, unless you have a really, really, really strong reason for doing otherwise. Now, why would you do that? What if you have 20 different variables that use the value of pi, 20 different functions? Const double pi equals 3.14159, right? I don't want to just have to type in 3.14159 7,000 times through my program. And I have 20 different functions making mathematical calculations that depend on pi, so I don't want to define this inside every function. Well, I can just define it once as a global variable, and then all my functions can use that value. That's a good use for global variables. Use global variables to hold constants. The keyword, what are you Java programmers? Tell me what the same keyword is in Java. It's not the word const. Anybody remember? It's final. I don't know why Java, which was invented after C++ and stole so much of the C++ syntax. I don't mean stole in a bad way. Borrowed, used, change that word to be final rather than const. Kind of like, is that your final answer? Yeah, is that your final value? It is. So that's a good use for global variables, is to hold constants that are used by more than one function. You know what, these classes should not be quite as long as they are, in my opinion. But I know we have to go through a lot, and I can't complain. But again, we might wind up leaving 15 minutes early. Arithmetic operators. Unary, binary, ternary operators. Aren't we using some fancy terms now? Unary just means that it has one operand. Well, what's an operand? An operand is a piece of data that the operator works on. If you have this, 3 plus 4, what is the operator? The operator is a plus sign. It has two operands, 3 and 4. Well, There's not a whole lot of unary operators. Unary means it has just one operand. Something with two operands like this is a binary operator. There's lots of binary operators, right? 3 plus 2, 3 times 2, 3 divided by 2, 3 minus 2. All of those are binary operators because they require two operands. They require two pieces of data to work, right? So plus, minus, multiplication, and division are binary operators. However, what if you have this? Operators. What if you have this? X equals minus 3. Now the minus sign only has one operator. How is this really treated? It's kind of treated like this, right? That's really what it means when you have a minus sign in something. But it's crazy to type. Nobody types like that. So here, the negative sign is a unary operator, meaning it only has one operand. Are we going to see very many unary operators? Not really. The most common one we're going to see is plus plus and minus minus, which means add 1 to the variable or subtract 1 from the variable. And yeah, we're going to use the minus sign. But otherwise, you know, most of your math is done with binary operators. Not binary meaning it's all zeros and ones, but that it takes two pieces of data for it to compile. What do I mean by that? What if I type this? Oh, I need to get rid of that, don't I? By the way, if you have any syntax errors because you were following along with all these changes I was making, compile and run your code and make sure that there aren't syntax errors now. Mine sure does have them. All right, I'm just going to start deleting stuff until I don't have the syntax errors anymore. Because I want your code to be in a working state if you're trying to get into a working state. So, binary operators take two operands. And then there's the weirdo one, the ternary operator. What do I mean by a weirdo one? If you have never seen this syntax before, even if you've done programming in other languages, it looks a bit crazy. I'll show you what I mean. Int value equals pounds greater than 0, question mark, 1, 2, 3, colon, 4, 5, 6. That is a valid syntax. Called a ternary operator because it's got three pieces. It's got something before the question mark, it's got something after the question mark, and it's got something following a colon. That's a ternary operator. What in the world does that mean? Here's what it means. It means if pounds greater than 0 in parentheses, then value equals 1, 2, 3, semicolon, else, no colon after the else, you Python people, value equals 4, 5, 6. It's just a shortcut way of writing that. This is a lot clearer. However, C++ is not the only language to support what's known as the conditional operator or the ternary operator. See, now that we look at it again, we can kind of read it. Is pounds greater than 0? Then set value equal to 123. Else set it equal to 456. Now, on the rare occasion where I feel like using the ternary operator, I go ahead and enclose this part of the expression in parentheses because that makes it real clear, or at least a little bit clear, what's going on, right? That this will be evaluated and then it's checked. And if it's true, then that gets copied, else that gets copied. But you don't see textbooks doing that. They leave that off because it's not strictly part of the syntax. So that's the ternary operator, also known as the conditional operator. If the part in front of the question mark is true, the value before the colon is used. Otherwise, the value after the colon. So like this, string state, int number equals 32. State equals, I am going to go ahead and use parentheses because I think it makes it look clear. Number equals 0, end parentheses, question mark. Is number equal to 0? Quote 0, end quote, colon, quote, non-zero, end quote. Like that. After it's done, state is either going to equal the word 0 or non-zero based on what the number is. If the number is 0, then state equals the word 0, else it equals the word non-zero. It is a nice, succinct, terse, non-verbose, whatever fancy word we want to use, way of stating something. But it's almost too clever by half. You know, I could do it with an if statement and it would be more instantly obvious to somebody reading the code. But a lot of programmers don't like to make things instantly obvious. So once you learn this syntax, then it makes sense. So that's what the ternary operator is. You're not going to see me use it very often other than to demonstrate it here and then ask you about it on the exam. So I think it's a quiz question as well. You know, what is it? Hope so. So that we'll get it right. What if we wanted to set state equal to even or odd, based on whether the number was even or odd? State equals, how could you check to see if a number is even with an if statement?
The modulus.
Modulus, exactly. If number modulus 2 equals 0, if you divide it by 2 and it has no remainder, it's even. So number modulus 2 equals 0, into parentheses, question mark, even, end quote, colon, quote, odd, end quote. And it would work just as well without the parentheses, but I think it just makes it easier to read. We haven't talked about Boolean variables much, so I'm going to throw one in on you here. Bool negative equals number less than 0 colon. Excuse me, semicolon. And it's not a ternary operator. But bool is something that can be either true or false. What happens? This part of the equation is, this expression is evaluated. And if it's true, then true is placed in here. And if it's false, then false is placed in here. Gee, my phone's loud all of a sudden. Shut up. Okay. Hope that makes sense. This expression is calculated and stored over here, just like this said 1 plus 2, right? If we had 1 plus 2 on this side of the equal sign, then 3 would be copied over here. The mere fact that this is a Boolean and this is a logical expression doesn't change that. This expression is evaluated. It's either true or false. Is number less than 0? It's either true or false. In this case, number is 32, so it's false, right? Number is not less than 0. So it's going to store false into that Boolean variable. And then we can do an if statement based on it. If negative, into parentheses, cout, number is negative. Exclamation point, backslash n, end quote, semicolon. Boolean variables are also known as flags. That term is used so commonly that it's even in textbooks. This is a flag, right? We set a flag. And if the flag, is set, then we do something. Well, okay, so negative is a flag, and if that flag is set, then we print out a message. Quite commonly, that's used for error messages, right? If error, then do something. So you set a flag, you set the error flag, you may hear a term like that. All right. We are going to make some homework based on this stuff. But dude, you've been talking for 2.5 hours. How am I going to know which? Okay, I'm going to highlight exactly what the homework is going to be based on. It's going to be based on using modulus for conversions. Remember when we turned the number of pennies into quarters and cents? Or we turned the number of ounces into pounds and ounces? We're going to do something very similar. So what are we going to do? That's not it. That's our Python homework. There he is. That is not it. Okay, fine. I'll recreate it on the spot. So homework. Set miles. Set m, which means miles, equal to 10,000. Then calculate the number of miles in feet using modulus. Hint, how many feet are in a mile? It's a pretty weird number. There are 5,280 feet in a mile. 5,280 feet in a mile. So display the miles and the feet. Just like we did the, I don't remember if we did ounces and pounds or feet and inches, but just like that. That's one problem. But of course, that can't be the only one. That'd be boring. So, set, I have to look. We did use ounces and pounds, so let's come up with something else, some other kind of conversion. How about dollars and cents? We did quarters, right? Set pennies equal to 654. Calculate the number of dollars and cents. Hint, there are 100 cents in a dollar. And so after we calculate them, of course, we're going to display the number of dollars and cents. Now, it could be that you could just copy and paste the code that we took and make like 12 changes and be done with it in 45 seconds. Don't do that. Don't take our code that we've already written, copy and paste it, recreate it, right? You'll learn a little bit more. You still might be able to do it really fast. And yeah, if you get stuck, look at our notes, right? You're going to look at the notes, but don't just copy and paste it in order to accomplish this one. And in general, that's true, because quite often I make our homework look a lot like what we did in class. Why? Because I'm teaching you how to do it, and I want you to do it. But if you copy, change, done, you didn't learn as much. So do recreate it. I mean, unless it's 10,000 lines of code, right? But I'm not going to make 10,000 lines of code that you would need to copy. So that's the homework assignment. Does that make sense? You see what we're doing here? All right, there's going to be a quiz over Quatloos and Tribbles. Maybe not. Let's look at our slides, see if there's one or two more we want to cover. Arithmetic operators. This is important. I'm glad I scrolled ahead. The divide by operator is a tricky, shifty little beast because it does two completely different things. based on whether the data is floating point or integer. Let me show you what I mean. Go ahead and go up to the very top of your program, just so it's really easy to find. Or the very bottom of your program, above the system call. We're going to declare a variable, and we're going to make it equal to something. Double, so it's going to be super precise. Third equals 1/3. Looks pretty clear, crystal clear. C out, arrow, arrow, quote, third equals space, end quote, arrow, arrow, third, arrow, arrow, ENDL. Before you run it, somebody hazard a guess as to what it's going to print. And if you know the answer, that's great. If you don't, that's great. What's it going to print? Who thinks it's going to print 0.333, or at least that it should? Is that what it should print? 0.333? It's what it would do in Python. Nobody's raising your hand. Come on, guys, be brave and bold. No, it's not going to print 0.333 or 0.333. I swear it would in Python, right? If I come into Python and print 1 divided by 3, okay, I'm expecting to see that in C++, and I'm not going to get it. I'm going to get the number 1. It's also true of Java. This is not just a C++ quirk. It's equal to 0. I said it was going to equal 1. I was wrong. It equals 0. Not good. What did it do? Why did it do that? Because that's an integer and that's an integer. And in these languages, and in the C languages, including Java, an integer divided by an integer produces an integer, meaning it rounds down. And so 0.333 rounds down to 0, which you don't expect. How can you fix that? Change either one of them or both of them to floating point. If you do 1.0 divided by 3.0, now we're going to get our variable. That looks good. And there we go. Now we got 0.3333. That can be more subtle than you might expect. Like the formula converting from Fahrenheit to Celsius looks something like this. Let's see if I got it. I'm just going to type it in here. Yeah, why not? I'm just going to type it in here. Celsius equals F minus 32 times 5 divided by 9. That's the formula for converting from Fahrenheit to Celsius. And then when you run this, you're going to get 0 or something. You're probably going to get 0 if we ran this command and this was an integer, if f was an integer. Why? Because what's 5 divided by 9 rounded down? Goose egg, right? And so the whole thing would be multiplied by 0, and so your Celsius temperature is always 0. Subtle error. I mean, right? I mean, that's a logic error. You never had to worry about that in Python because division just worked as expected. So to get this to work, change one or both of them to floating point. And now it does exactly what you want. So when I'm giving you formulas, I try not to trip you up. Like the value for the surface area of a sphere is 4/3 pi r cubed. I hope that I'll say it's 4.0 divided by 3.0. But I might not. I might just put 4 over 3, and then you're going to have to remember. But what's 4 over 3 rounded down? 4 over 3 rounded down is just 1, and so we're not going to get quite the right answer if we do that. So whenever you're doing division, make real sure that you're not wanting to do integer division, that you're not wanting to round. And if you're not wanting to round, make one of them or both of them floating point values. That kind of makes sense. That'll bite me up here when I'm demonstrating something. I bet I'm going to wind up doing the 4 divided by 3 times pi r cubed and going to get the wrong answer just because I didn't mean to do it, but it's because I give so many Python examples where I don't have to care about it. 2 integers divided equals an integer. 1 integer divided by a float is a float, right? I did not have to change both of them. That would equal 0.333. If I did the reverse, that equals 0.333. If I do them both, so much better. Still equals 0.333. Didn't change it. It's just that one of them has to be a floating point to stop it from doing integer division. The parts of the chip that do floating point division are just stored in a completely different part of the chip than the integer division. And integer division happens 1,000,000 times faster than floating point division. I'm exaggerating slightly. But integer division is the fastest operation that a computer can do. Fastest kind of math that it can do. So they made C so that it supports integer operations. I think we have lectured enough, in my opinion. Any questions over the homework? We're all going to be able to install Visual Studio and get this done in a week. Yes, sir.
It's just over those two things, like changing miles to miles and feet.
That's it.
Dollars and cents.
Exactly. That's all we're going to do is the miles to feet and miles. Excuse me. Yeah. Did I write that right? Let me look at my notes. Okay, that was dumb. Because 10,000 miles is going to equal 10,000 miles, right? And no feet. That was stupid. Set FT, which means feet, to 10,000. Sorry for that mistake, gang. Thank you for clarifying that. I would have sent y'all off and you would have wondered why in the world I was telling you to convert from feet to feet. How many feet is in 1,000 feet? 1,000. All right. So if you were typing these notes in, the homework assignment, please make that correction. Just change that line. I'm going to change that word set to int. There. Just rewording a little. Alrighty. Any other questions? Thank you for asking that one. You're my new best friend. Anybody else?
Were you gonna send a quiz?
Yeah, let's put a due date on the quiz, but remember that after the quiz is graded, you can take it again. Do we have a chapter 1 quiz, or did I just totally blow that one off?
You didn't assign it out.
Yeah, there is no chapter 1 quiz at all. So let's make a chapter 2 quiz. Or what I mean, make it. We're going to enable the chapter 2 quiz. We're not done with chapter 2, but we will be done with it by Wednesday, so we're going to make it do a week from Wednesday. And I could enable the quizzes, all the quizzes, so if you wanted to take them early, you could. There's nothing wrong with you taking a quiz early. And you probably know enough already that looking at the PowerPoint in the book or whatever, you could go ahead and take the chapter 2 quiz as soon as possible. I'll try to grade them as soon as possible so that you know how you did. And it may, yeah, unlimited attempts. That's exactly what I wanted to say. And keep the highest value. So you'll just be able to take it over and over until you get the grade that you want. Very good question. Let's make a Dropbox for ourselves and skedaddle.